Okay. And then we have, of course, our butanone, which is a ketone with 4 carbons. Again, actually, you don't need a number here in this case. You can still put the 2, but it's 1, 2, and if you were to go this way, let's say it was on this carbon, it would be 1, 2. So actually, the only place for it to possibly be, to be a ketone in this case, would be on carbon number 2, no matter which way you looked at it. If it was on this carbon or this carbon, it would have been an aldehyde. Okay, so reactions. So if you remember when we did alcohols, there's 3 kind of categories of alcohols. We have primary, secondary, and tertiary. So if you need a refresher on that, please go back and make sure you take a look at that. So one oxidation, pardon me, one type of reaction that aldehydes and ketones can be produced with, it's called an oxidation reaction. Okay, so you're going to see this come up again later on in this course. But an oxidation reaction in terms of organic chemistry reactions is essentially where you have a molecule that's either gaining an oxygen or losing hydrogens. Okay, so regardless of what type of oxidation is happening, you need to add what is called an oxidizing agent. Okay, so one of the reactants is going to be an oxidizing agent. So you'll see here it has basically an oxygen that's being shown in brackets. Now, does that mean it's an oxygen that's in brackets that's going to be reacting here? No. This is actually representing a reactive oxygen. Okay, so meaning it's an oxygen atom that is essentially looking to create bonds. So it's an oxygen that needs 2 bonds, and this reaction happens actually very quickly. So where do we get this reactive oxygen from? So there are 2 sources. There are many oxidizing agents that can be used, but there's 2 kind of general sources that are quite easily available. So one is hydrogen peroxide, and the other is potassium permanganate. So the reaction will never say plus hydrogen peroxide or plus potassium permanganate. It will always have this symbol representing a reactive oxygen that is coming from one of those 2 substances. Okay, so when you're doing this, you're not writing that out, but it's assumed that it's coming from a reactive oxygen source. Now, is it only these 2 that are possible? No, there are many different types of oxidizing agents, but really all you need to know is that you're adding a reactive oxygen. Okay. So when you add this reactive oxygen, depending on what you're adding it to, will actually determine the outcome. So when you have a reactive oxygen or an oxidizing agent being added to a primary alcohol, the primary alcohol, that's bothering me. The primary alcohol, again, is where you have the carbon that has the OH on it that has only one other carbon atom. The primary alcohol will oxidize to become an aldehyde. Okay, so primary alcohols become aldehydes. So let's take a look at what is happening to create that aldehyde. Okay, so we're doing the option here of an oxidation where you are losing hydrogen atoms. So what's happening is actually the hydrogen that's on the OH will go on to the reactive oxygen. And one of the 2 hydrogens that are on that carbon will also go on to that. Okay, sorry, my dog is here. Just ignore the sounds in the background. When you're doing this, right, so basically the oxygen loses a hydrogen and the carbon loses a hydrogen, and that creates water. So that oxidizing agent essentially becomes water. What's happening now? You have 1 carbon that has a bond left unfulfilled. This oxygen has a bond left unfulfilled, so they create a double bond with one another. Okay, so very similar to a dehydration reaction. What's unique here is the source of the other oxygen. Okay, that's unique. So a secondary alcohol. When a secondary alcohol, same thing, you're going to add an oxidizing agent. When it oxidizes, it produces a ketone. So secondary alcohol is when the carbon that has the OH has 2. Sorry, I had a little bit of an editing thing happening. Okay, so your secondary alcohol is when you have the carbon that has the OH on it, has two other carbons attached. So the what's actually happening here is the exact same thing. The H that's on the OH group goes onto that reactive oxygen, and the hydrogen that is on the carbon is being removed as well to create water. And of course, the C and O create a double bond. It just so happens to be that this carbon is in the middle of the chain and not at the very end, which is what a primary alcohol would be. Okay, so we didn't talk about tertiary alcohols, and that's because tertiary alcohols are not oxidizable or not easily oxidized. Okay, so the reasoning why is if you look at the mechanism, remember what's happening here. The H from the OH and an H from the carbon is what creates the water with your reactive oxygen. Over here with a tertiary alcohol, you do not have another hydrogen to actually create that water. So what ends up happening is this oxygen is going to be left without a bond, and this oxygen will be left without a bond. So it's creating instability. So essentially, if you're ever looking at a reaction and you're asked to say the products, you would say no reaction. Similar to if you remember in grade 11, single displacement reactions, it doesn't always happen. You would put no reaction. Same deal here. So remember that your oxidizing agent can be potassium permanganate. This one wasn't in the other note, but essentially it's a dichromate ion. Also hydrogen peroxide is not listed here, but that's another common one. So again, you don't really necessarily need to know which source you're using. You should know, hydrogen peroxide is kind of an easy one to remember, but the point is that it is an oxidizing agent, and what's happening there is it's giving off a reactive oxygen that's ready to bond. Okay, so our last type of bond, so we have oxidation, or I should say last type of reaction, is a hydrogenation reaction. Okay, so hydrogenation reactions will sound familiar. We saw hydrogenation where we had an addition reaction. This is literally the same thing. So if you remember, a hydrogenation reaction is where you have a double bond or triple bond that is breaking and you're adding in hydrogens. You're doing the same thing here. The literal only difference is instead of it being a C-C double bond, it's a CO double bond. So what happens is if you have an aldehyde and you add hydrogen, this bond will break, right? So this bond breaks. You end up getting one hydrogen going to the oxygen, one hydrogen going to the carbon. So what ends up happening is you now have returned, it's kind of like the opposite of doing our oxidation. So instead of having our primary alcohol becoming an aldehyde, our aldehyde is becoming a primary alcohol. And of course, if you have a ketone, you're again breaking this double bond. One hydrogen will go to the O, one will go to the C, and you end up having a secondary alcohol. So it's pretty much the exact reverse. But hydrogenation still nonetheless, you're breaking a double bond and you are adding in hydrogens.